This is a video for AQA Further Pure Mathematics Calculus, section 1.3. We're looking at volumes of revolution, this time rotating about the y-axis. We can see from this diagram that when we're rotating about the y-axis, the radius of the disk that we get is going to be given by x, and the width of the disk is delta y. So when we had in volumes about the x-axis, we had that the delta v was pi y squared delta x. In this case, we've got delta v is pi x squared delta y. Once we've done that, then the rest of the process is exactly the same, where we're just taking limits, so we can sum to get an approximate volume, and then take the limit to give us that the volume is an integral from y is equal to c up to y is equal to d of pi x squared delta y. So again, note that it's pi x squared, but the integration is with respect to y. So here we're asked to find a volume of revolution when the curve y equals 2x to the power 0.5 or 2 root x is rotated about the y-axis, and we're looking at from y equal to 2 up to y equal to 4. So the volume will be equal to the integral from 2 up to 4 of pi x squared dy. So if y is equal to 2x to the power a half, then that means that x squared must be equal to y divided by 2 all raised to the power 4. So that gives us the value of y to the power 4 over 16 for x squared. Therefore the volume is equal to the integral from 2 up to 4 of pi y to the power 4 over 16 dy. So note that we had to make a substitution there for x squared in terms of y. Once we've done that, then it's relatively straightforward to do the integration. Taking out the pi over 16 as a factor, we've then got y to the power 4 integrated, so that becomes y to the power 5 over 5, and we're evaluating that between 2 and 4. So just going over that again, then remember that we wanted the volume to be the integral of pi x squared dy, so we needed an expression for x squared. So we need to take the function y equals and rearrange to give x squared equals, so we can substitute into this general formula. So there's the solution written out again. So there's the substitution going on there for x squared, it being the y to the power 4 over 16, and then the integration afterwards. Let's consider the following then. If we had the region bounded by the curve y equals x squared minus 3 and the lines y equal to 4 and 5, which of these would be the correct calculation that you'd need to do? So pause the video for a while just to work through this and see what you come up with, and perhaps you might consider why each of the other ones is incorrect. Well, we know that y is equal to x squared minus 3, and therefore x squared is equal to y plus 3. And as we want the integral of pi x squared dy, then we can see that the correct one is the second one down. And we might consider why the others are incorrect. The first one there is pi y squared dx. So this is the integral of pi y squared dx. So this is a rotation about the x-axis rather than the y-axis. The third one down there, certainly the pi y plus 3 is correct, but what's missing is pi, so that should have been pi. And in the last one, we've got the pi y plus 3, but the variable there is written as dx, and it should of course be dy. Well, that ends this video, and in the next one we'll be looking at how we calculate the mean of a function.